Alright, welcome back to this video. In this particular video, we're actually going to learn how we can actually minimize our error, right? How we can minimize our error. Okay, because if you plot this sigmoid curve, it's likely that some of the points are not going to lie on the sigmoid curve, right? Some might lie somewhere. Okay, and how do we actually minimize this kind of error, right? How do we minimize this kind of error so that most of the points will lie closer to this, right? Most of the points will lie closer to this and not far away from that, right? We're going to see what is the effect of a point lying far away from a sigmoid curve, right? And the effect of a point lying closer to this, right? So we see all that in this particular video. All right, so let's get started. Now in the linear regression class, right? In the linear regression class, we talked about what is called the mean square error, right? We talked about what is called the mean square, right, error. We talked about what is called the mean square error, where let me just pick an example here. So let's say we have the MPG. Remember that we use in the linear regression class, we use the MPG, which is the cow's miles per gallon. Okay, so we use that one, right? So that becomes our target variable, right? Or you can also represent it as y. Okay, you can represent it as y, and then we made some predictions. Okay, we made some predictions, so you can represent the predictions as y hat, right? You can represent the predictions as y hat. Now, if we have this kind of a situation, right? We have this kind of a situation. What happens is that if you predict maybe the actual miles per gallon of the car is say 20, right? It's say 20, and then our prediction, right? After we build the algorithm, we're able to predict that the miles per gallon is say 19, right? Although it's closer, but it's not exactly 20. Our prediction was not 100%, so we did not actually get 20. Okay, maybe something like the miles per gallon was maybe something like 30, and then we predicted say 25, and then maybe another one was say 19, right? And then we predicted say 15, something like that, or we predicted say 23. Okay, we did something like that. Now what is happening here is that there is difference between the actual and the predicted, right? That's why when you plot it and you plot the linear regression line, you can find some of the data points lying somewhere, not exactly, right? If it lies exactly on the line, it means that when it was maybe the point was say 15, right? You were able to predict 15, right? Which means that this one is exactly what is there, and we're able to predict exactly that. So that point will lie exactly on that regression line that you're trying to fit. But normally the points are actually going to lie somewhere a bit far away from the regression line. But what we want is that the points should lie a bit closer to the regression line, not far from the regression line. So what is going to happen is that we want to measure the distance between, right, the distance between each of the points and the line, right? So the distance here is what we refer to as the error, right? So the error or the mistake that we did in predicting the data point. So maybe the data point, the original one, right? Maybe the original one was maybe 30, we predicted 15. So there was an error of 5. There was an error of 5 here. So that could be the distance over here, right? That could be the distance over here, right? So we will measure it for each of these data points. We will measure it for each of these data points, and then we sum all the errors, right? So we are going to do for the actual, right? For the actual minus the prediction, minus the predicted one, right? Then we square it. Okay, then we sum it for all of them. So for all the data points over here, we will find it, right? The predicted one and then the actual one. Okay, we sum all of them, then we divide it by the total number. So this becomes the mean square error, right? MSE, right? This becomes the mean square error. Now if we find the root of that, right, in order to get it, get our result in the same unit as the data points, right, then we are going to have RMSE, right, which is the root mean square error. Okay, this happens in linear regression, right? This happens in linear regression. Okay, this happens in linear regression. But don't forget, in logistic regression, we are not actually using a linear, we are not plotting a regression line, a linear regression line. So we cannot use the mean square error over here. We cannot minimize the mean square error, right? We cannot minimize that, right? Mostly what we do is to minimize the sum of square error, right? So that's what you can find over here. What we actually want to do is to minimize the sum of square error over here. But in this case, we are not actually using a linear regression, right? We are using a sigmoid curve, so we cannot actually minimize the sum of squares, right? What we can do is to actually minimize what is called the log loss, right? We can minimize what is called the log loss, or well, I mean, some people also call it cross entropy, right? People also call it cross entropy. Okay, so we can actually minimize all this, and let me show you what this equation looks like, right? The log loss or the cross entropy. So we'll be having this, right? Negative y and then log, right? Log of y hat, that is the original data points, and then the predicted one, okay, minus 1 minus the original, right? 1 minus the original, and then log of 1 minus, oh sorry, log of 1 minus the original, that is log of that. Okay, so basically this is what we refer to, let me pick this, right? This is what we refer to as the log loss or the cross entropy, right? The log loss or the cross entropy. So let me just break this thing down for you. Let me just break this one down for you so that you get to understand. So what is happening here is that if our y, right, if our y equals 1, right, if we think about this equation, if y equals 1, it means that this one is actually going to go to 0, right? Because we are going to have 1 here, and 1 minus 1 is actually 0, and 0 times this is actually going to make the whole of this 0. Okay, and then we only be left with this one, so we are going to be left with minus y log this, right? You're going to have something, even we are saying that y equals 1, so this will even be 1. Okay, so let me just even clear this one. Okay, let me clear this one, because over here, right, over here we are saying that if our y equals 1, so this one is even going to be 1, right, and this y is also going to be 1. Okay, so if this is 1, then it's going to be 1 minus 1, then it's going to give you 0, and this is going to go away. And if this is 1 here, right, we're going to have 1 times this log of y hat, then we're going to have this. Okay, now what if y equals 0, right? If y equals 0, remember that at the sigmoid, right, at the sigmoid we have 0 and then 1. We only have 0 and then 1, right? But if we are making a prediction, right, this is the actual is always 0 and then 1. That is whether a student will fail or pass. Okay, whether a student will fail or pass, that's what we're having, right? But if you're making a prediction, right, that could be a probability that could lie in between 0 and 1. So this could be maybe 0.8, right? So our y hat could be a probability, right? It could be a probability between 0 and then 1, right? So greater than or less than that, right, between 0 and 1. But our y, right, that is the original y, is actually going to either be 0 or 1, right? That is whether the person will fail or the person will pass. Okay, so let me clear that part. Okay, so now if we have our y, right, we have our y. If we have y equals 0, then this one is going to be 0, and this is going to be 0. The whole of this is going to be 0. And then here, our y here, right, remember this is just y. Right? If this is y, then it's going to be 1 minus 0, right? 1 minus 0 is still 1, right? And 1 times log, 1 minus y hat is still going to be the same. So over here, we're going to get negative. We're going to have negative. Remember, this is even going to be negative, right? This is going to give us negative when y is equal to 1. And this is also going to be negative, right? Because the whole of this is going to go away. We're going to have negative this, and 1 minus 0 is actually going to give us 1, and 1 times this is going to give us the same thing. So we're going to have log of 1 minus y hat. Okay, so if y equals 0, we have this. If y equals 1, we will be having this. Okay, this is what we are actually going to have. So basically this equation, that is what this equation is actually telling us. Okay, this is what this equation is actually telling us. Now let's try and then see why we always want to minimize this log loss or this cross entropy, right? Let's try and then get to understand that. So I'm going to draw the same thing that we're dealing with earlier on. Let me do it like this. So we're having this, okay, we're having that, And then we have 0, we have 1, that's whether the person will pass or the person will fail. And then we have 1, we have 2, we have 3, we have 4, we have 5, we have 6, right? So we can have more of that. Okay. Now this is what we normally have, right? This is what we were having earlier on. Then we have some data points here. That is some of the students who studied for less hours and they failed. Okay. And there were some anomalies here, right? Some of the students who studied for less hours, but they still passed, right? So something like that. So let me just put it here, okay? Or maybe let me just bring it here. So let me just bring this. Let me just put to this point here. And then there were some students, right? So let me just do this. I think that will make it clear. So this is the one, right? So this is the one line. So let me bring it here. Or maybe I should use black here. All right. So I'm just going to trace this one and then bring it somewhere here. Okay. Now let's go back here. So there were some data points which were, some students who study for long hours, right? So some students who study for long hours and they passed, right? So those students are going to be here. Okay, and there are some students over here, right, that they actually study for less hours, but they passed, right? They passed. Unlike these students who study for long hours, but they still failed. Okay. Now let's try and then do let's try and then join what we did earlier on, right? Let's try and then do that. Okay. So this is our sigmoid curve that we drew earlier on. Okay. Now let's try and then find the intuition behind the reason why we need to minimize the cross entropy or the log loss, right? So that we will get we will get to the best sigmoid curve, right? So let's try and then see that now. Now from above, right? From above, we say that if y equals 1, then we have negative log, log of y hat, and if y equals 0, then we have negative of log negative of log of 1 minus y hat. Okay. Now let's try and then see what is happening here. Let me just represent this point. So the points here, let me just represent them as a, right? Let me represent them as a, and this wrong classification point over here, let me label it as b, right? So let me label this as a, this b, this is a, this is b, and then let me label this as c. Okay, then the points over here, let me just label them as d, right? So let me just label them as d. Okay, so this is what we have. This is what we have. Now if we take the points that are around here at a, right, that is the points over here are 1, right? They are the ones that passed, right? So they are 1, right? So now if y equals 1, that is the points that passed. So if y equals 1, then the log loss that we are supposed to use, right? The part of the log loss that we are actually going to consider, right? The part of the log loss that we're going to consider is this. That is if y equals 1 is this one, negative log of y hat, right? We're going to consider negative log of y hat. Okay, that's what we're going to consider now. Now what is going to happen here is that if y equals 1, right? If y equals 1, and that is a point here, right? Now if we make some predictions on that, right? Our y hat, which is going to lie on this prediction line, right? Maybe somewhere here, right? Maybe if we trace it a little bit up, right? It's going to be a point here, but it's not actually as exactly as 1, right? Our predictions are not going to be 100%. Okay. Remember that this sigmoid curve will help us to make predictions, right? But our predictions are not going to be 100%. Okay, our predictions are not actually going to be 100%. It means that instead of maybe getting 100% accuracy over here, or maybe 1 as exactly as 1, right? Maybe our y hat in this case is going to be close to 1, right? Maybe 0.99, right? Something like that. Maybe 0.999. Something like that. Okay, so in that case we're going to have negative, or maybe let me just put it here, 9 over here. So let me just put it here. So we're going to have negative log of, remember this, our y hat, negative log of 0.999, right? Negative 0.999, something like that. And if we find log of 1, right? Log of 1 is approximately, right? Log of 1 is approximately 0, right? So we can say that log of 0.999, which is closer to 1, can be approximated to 0. Okay, we can approximate log of negative 0.9999 to be 0, right? You can approximate it to 0. Now that is if our y equals 1. Okay, that is if our y equals 1. Okay, now if we go down here, if we go to the point B, right, which is a wrong classification, right? Our B is a wrong classification. That is a point that is, I mean, like more like an anomaly, right? A student who actually studied for long hours, but the person failed. Okay, now if you see this point where the point is lying, it's lying very far away from the sigmoid curve, right? Now if we see this point and we try to make a predictions of this point, right, it might go all the way up, right? It might go all the way up, right? Also very close to 1, but not as 1. So now, but don't forget that down here, right, when it comes to down here, our original y, right, our normal prediction is that anyone down here is a failure, right? The person has failed, right? The person has failed. They study for less hours and the person failed. Those who are here study for long hours and they failed. I mean, they passed, right? Those who are here study for long hours and they passed. But those who are down here of our sigmoid curve study for less hours and they failed. So our original values here is 1, right? I mean 0. Okay, but if we see this one, right, if we see this one, that is our y hat, that's our prediction, right? If a data point comes in and that data point lies here, right, that's a new student who study for say 4.5 hours, right? A new student who study for 4.5 hours. If we trace it to our sigmoid curve, it's actually going to say that that person passed, right? Which is closer to 1, which is going to be more of 0.999, something like that, more closer to 1, okay? But originally, right, that person failed. That person failed, but our curve is actually going to predict that that person passed. Okay, that's actually a wrong prediction, so a wrong classification, okay? Now, if we have this situation where our original is 0, but our prediction is more closer to success, right? Our original is fail, but our prediction is more closer to pass. Okay, in that case, right, that is when y equals 0. So if we go to our log loss or the cross entropy function over here, if y equals 0, then we use this part of the equation. That's negative log of 1 minus y hat. Okay, that is negative log of 1 minus 1 y hat. Okay, in this case we're going to have negative log, right, negative log of 1 minus, now our y hat here is 0.999, right, something like that, 99999, right? You can increase it as you want because it's getting closer to 1. Okay, all right, so in this case, right, we're going to have negative log of, that's 1 minus this is actually going to give us 0. Maybe 0.00001, something like that. Okay, 0.00, which is almost 0, Now if we pick if we approximate it, right, it's actually going to be more like a log of 0, right? It's going to be log of 0. If you try to actually type this on your calculator, you might find that it's something closer to 9, right? It's something closer to 9 over here. If you can just pause the video and then try it on your calculator, and you'll see that it's actually closer to 9. Okay, now that is this. Now you can see the loss that we are having here, as compared to the loss that we have here when we are having right classification, right? So this is a wrong classification, and you can see what we are having here. If we consider this part, right, this is when y equals 0, right? When y equals 0, now our y hat, that's our prediction, right? If a student is here, right, if maybe a new student comes, right, and the person studied for say 1.5 hours, we can actually trace and then say that this, according to our sigmoid curve, this student will fail, and I mean under normal circumstance that student failed. Okay, so this one is actually something which is closer to 0, right? So we can see not exactly 0, but closer to 0, so we can see 0.000001 or something like that. Okay, which is very close to 0. Okay, now in this case, right, if our y equals 0, when you come to the log loss, right, or the cross entropy, if our y equals 0, then we use this part of the equation which is negative log of 1 minus y hat. Okay, so we're going to have negative log, right, negative log of 1 minus y hat. Okay, in that case we're going to have something like this, negative log of 1 minus, now our y hat here is 0.00001, something like that. Okay, now if we try to find this, right, on your calculator, you might end up seeing something like this: negative log of 0.999, 0.999, something like that, right? 0. That. And if we try to actually find this, right, I mean 0.999 is more approximate to negative log of 1, right? Something like that. Okay, because this one is actually almost 1. Okay, so if we try to find something like that, and then we can actually see that this one, the log of this, is actually going to be approximated to 0, because log of 1 is actually 0, right? So we can actually approximate this to 0. Okay. Okay, now we can actually see that when we have the right classification, right, the log loss is actually almost 0, right? Just like over here too, when we have the right classification, the log loss is almost 0, right? But if we have a wrong classification, just like this one, we can see that the log loss is actually higher, which is approximately 9, right? We can do the same thing for this one, and you find out that it's also approximately 9, right? Something like that. Okay, so if you have a wrong classification, the log loss is actually high, right? The loss that you get is actually high. But if you have a right classification, right, the log loss is almost 0, right? The log loss is almost 0. That's why we actually want to find the best sigmoid curve that will actually help us to get to minimize our cross entropy or our log loss. Okay, we want to find the best. So if we have several of these, right, if we have several of this, maybe another one sigmoid curve here, or maybe another one like this, right, another one like that, then if we compare the log loss of all these sigmoid curve, and then the one that will actually give us, that will help us to minimize these cross entropy or the log loss, right, is the one that's actually the best sigmoid curve and the one that we will actually use. Okay, so if you build your logistic regression and you actually finally use this log loss, right, if you perform this log loss, right, on that model, right, then if you find the kind of logistic, the kind of sigmoid curve, right, the kind of sigmoid curve that is giving you this, the lowest log loss, then that is your best sigmoid curve, right? Then that is your best sigmoid curve, and that's the sigmoid curve that you can take to production. Okay, that's the sigmoid curve that you can actually take to production. All right, so basically that is what I wanted to actually let you know, right? That is what I actually wanted to let you know. Okay, so in the next video, we're actually going to go into the lab and then see practically how we are going to implement this logistic regression, how we are actually going to build our logistic regression algorithm. Okay, so see you in the next